So I'll give a little intro of myself. My name is Sundarajan Mutialu, founder and CSO of AZENTIVE. We're a wellness and sustainability company, but we also do a significant amount of work in emerging technologies. And our whole goal is biomimicry and working towards any technologies that wrap around nature, because nature in our mind has already engineered it. On our panel today is Michael Stevens, and Michael has been an innovator in the cannabis community for the last 25 years. Michael studied chemistry at San Diego State University. He relocated in San Francisco, I think it was 1997, and he integrated into the sort of the Bay Area medical. And by the way, I was in that same medical arena as well, growing up in Berkeley and going to UC Berkeley. And during that time, he developed a number of popular cannabis hybrids, and probably the most notable is being Jedi cultivar. And the past 6 years, he's been working on the development of industrial process for micropropagation of cannabis starter plants. And he co-founded, how do you pronounce that? Meristematic. And in that arena, he is basically doing a very high-tech nursery that produces real clean starter plants. And the company also specializes in removing problematic cannabis pathogens and such. So what's your fun fact for us?
My fun fact is kind of related to that Jedi variety, that cultivar that I produced in the 90s. It was one of the first hybrids I'd ever produced when I first started working with cannabis, and somehow Jay-Z had gotten access to some of the flower product, and he must have been impressed because he had rapped about it on the Black Album, and it was kind of an early badge of victory, claim to fame, if you will, for my breeding expertise.
That's good. That probably helped you a lot in marketing, right? Yeah, it must have. All right, and to his right and your left, is that correct, is John Frank. John is owner of International AG Labs. John Frank is passionate about soil and food quality and has helped thousands of gardeners across the U.S. achieve better flavored produce by fixing their soil. He's located in Minnesota, I believe, right? Faribault, which is south. And he has developed a lab test called nutrient density analysis. I'm anxious to hear about this. It's a test to measure the mineral content of food. John has found that the same soil environment that makes great tasting food is the same environment that cannabis sativa in particular achieves its highest genetic potential. So what's your fun fact?
Well, we have growers all over the United States, but our most northern grower is in Bethel, Alaska, and he's a market gardener. He's got a drive-in, indoor, underground, refrigerated system where he stores his produce. He's like a rock star up there because he's got some of the best produce around. So he grows a lot of carrots and cabbage and stuff like that.
Cool. Very good. Very good. Next is Savannah St. Clair, and Savannah is a third-generation cannabis grower. She has both industry and academic experience in research and development. Her recent research focus has been on biomedical aspects of plant and soil science. On cannabis industry side, she has been focusing on the benefits and challenges of micropropagation on high-potency SoCal strains like OG Kush and Cookie, of which I partake. So we'll have to talk about that a little. All right. So what is your fun fact?
My fun fact actually doesn't have to do with work, but I enjoy practicing yoga and belly dance in my free time.
Very nice. Okay. Aaron Gray is founder and principal of AG Laboratory. Aaron brings over 15 years of experience. He is a certified crop advisor through the American Society of Agronomy and California State Licensed Pest Control Advisor. He has developed proprietary technology to the fertility and irrigation industry, and the founder of Central Coast Agronomy LLC that provides a variety of crop management services to the cannabis industry, particularly in San Barbara, San Diego? Where? Santa Barbara. And what's your fun fact?
Fun fact, well, I'm a family guy, and I enjoy bass fishing.
Oh, good, great.
I like to get outdoors, and it's about it. Not as fun as you can get, maybe.
Okay, good. Let's see, my fun fact. My name is Sundarajan, so it took me, I think I was 10 before I could say my name. So anybody can call me son if you want, because that's what my dad did. And it's just a lot easier, right? Okay, let's see if this thing works. There we go. So that's the panel moderator introduction. I think, what's wrong? Okay. So where I think the soil science and plant genetics, this particular panel, where would we be without agronomy? Our flora, whether, you guys can pretty much read this. So the question is, where would we be without the soil? And where would we be without this plant and the environment? And looking at nature, and I think some of the questions there, through aligning with nature and breeding, seeding, and feeding, along with maintaining that soil, you get beautiful plants. And if you don't, most people know what they get. So that's what the panel is all about. So I'm going to have Michael get up, Michael, and go through your slides. Sure.
So this slide here really covers defining the true nature of what tissue culture is. Really what we're looking to do here is create an aseptic culture of cells or tissues or organs under conditions which lead to cell multiplication or regeneration of organs or the entire organism. This is a commonly used definition for tissue culture pretty much across the biotech spectrum. Tissue culture has a lot of kind of fundamental components to it. In a certain respect, I'll kind of take a step back from the slides and kind of comment on what Sun brought up is, we look at the plant somewhat differently than a lot of the other people on the panel. We look at it in isolation from the surrounding environment. And we want to understand in detail what those cells do kind of on their own. And so we're able to do that by first sterilizing that tissue and putting it into a sterilized vessel. Now, where tissue culture is somewhat similar to a lot of the soil optimization and nutrient optimization that my fellow panelists are specialists in, is that we do supply nutrients in the growth media. And just like with soil, there's a certain amount of science that goes into optimizing these medias to ensure that they have the right nutrients for that specific cultivar. And in the case of cannabis, we do see that even some of the sub-varieties actually perform different using kind of standard tissue culture media nutrients. So we kind of start off with the initial tissue, which is rinsed. Some tissue cultures come from the stem. Some can be taken from a leaf stamp. It's not uncommon for roots to be cultured. All these can offer beneficial insights into the fundamental nature of your specific crop. Growth medias for tissue culture are really where the art is, if you will, and the science, frankly. We're supplying the plant cells with sugars, so they don't necessarily have to rely on their own internal photosynthesis to feed those cells. So we're artificially supplying salts, sugars, growth regulators, and vitamins to ensure those cultures can grow in a normal morphology inside that vessel. A tissue culture vessel is usually a test tube, or in the industry we call them magenta boxes. A baby food jar could even be used as a vessel, and even sometimes specialized bags can also function as a tissue culture vessel. Last but not least, fundamentally important to the cultivation of any plant or living cell is going to be its environment. You know, with tissue culture, we do manipulate light, temperature, and the gases within the vessel in order to kind of achieve our goals. Here you can kind of see meristematic 6-stage proprietary micropropagation process. We start off with isolating cannabis meristems. We validate those meristems through a PCR process to ensure that we don't have any foreign organisms present in those cultures. From that point, we take the meristem and it's grown out into that second phase, which allows us to establish noble-based culture. From there, we move into a multiplication focus, where we're producing multiple nodes that will be subdivided and transferred into new vessels. Later on, we have an acclimation process where the plant material is actually pulled out from the sterile septic environment and is now forced or is trained to acclimate to a traditional greenhouse environment without suffering any negative impacts. Lost. There we go. Third is getting it fully rooted and ready and kind of in the format that the cannabis industry is used to seeing, kind of that 1-inch standard rooted plug is kind of the current deliverable format for the industry. So we end up finishing our starter plants into that kind of industry standard format, and then they go out at scale to cultivators. Now, why would we want to do this? The current paradigm of clone production is basically outdated. Unfortunately, when it comes to clones, not only are you getting the genetic material, which is what the cultivator actually wants, but you're usually getting a lot of endophytes and other problematic organisms with your cutting. A good example of that is getting a cutting and putting it into the flowering environment. It appears clean and healthy and normal at first, but later you may realize that there was an organism present that was unseen. By starting off with the micropropagation tissue culture process, we can prevent and mitigate those types of infestations during the early part of the starter plant production. This allows us to not use systemic pesticides during our process as well, and we don't have to allocate excessive amounts of labor or square footage to having overly abundant mother plants. So here are some examples of highly optimized tissue culture systems with other commercial crops. These were some of the crops that we took a look at when we wanted to do our modeling for cannabis micropropagation. And one of the most successful kind of systems out there is some of the orchid micropropagation that's based in Asia. They have come up with a highly sophisticated and efficient production chain that is broken up into small subsectors, with each company kind of focusing on a small subsector. This has reduced costs dramatically over the past 40 years when it comes to purchasing an orchid. In the 70s and 80s, a single orchid would cost you hundreds of dollars. Today, you can buy one at a Walmart for $6. A lot of that has to do with micropropagation technology and the development of a highly efficient production chain. Second is sugarcane micropropagation based in Brazil. Brazil uses sugarcane as its core material for its bioethanol program, and thus they need large amounts of starter plant material. So they've looked to micropropagation to effectively produce sugarcane starts at scales in the multi-millions, and have effectively developed a broad range of systems that allow them to achieve scale not really seen with other crops. Last and somewhat close to meristematic's heart is the soybean and R&D development that's gone on here in the United States. Tissue culture is also very fundamental to advanced crop breeding and, in some cases, unfortunately, the making of genetically modified crops. In some cases, like I was saying, crop optimization relies on tissue culture for R&D purposes, more so than, let's say, production purposes, but is a fundamental key part of soy development here in the United States. And that's it. Thank you very much.
John?
I started working in a laboratory in 2001, and my first job, I was an employee, and my first job was to start answering phone calls. And I answered phone calls from people all over the country, and here's what I kept getting all the time. You know, you guys know how to fix soil, yep. You guys are helping farmers, yep. Can you tell me where to get that kind of food? And everybody wanted better quality food. And I kept saying, well, you're going to have to grow it. And so we ultimately started a division for gardens. And this was really good because people are willing to spend money on gardens. They don't really have a budget. They want to do to get the very best quality. So I learned a lot of things, and I researched and studied a lot of people from previous generations who'd gone before. And so after working with gardens all around the states and helping people, I saw a lot of patterns and problems, and so I stepped back just a little bit and I asked myself, what are the best soils in the world? And so I'm going to ask a question here. Think of coffee or tea or grapes or wines. Where do they come from, the best ones? What would you say would you characterize the best soils? What's that? Amazon? Brazil? I would just classify it as volcanic, or volcanic inputs, okay? And volcanic soil is known to be some of the best soils in the world. And so that's one answer. And then another answer that I was looking at, what are the best soils in the world? Is they're very rich in calcium. It's a really adequate, plentiful supply of calcium. And when you have those two together, you get a third thing that's really important. And that is the soils become teeming with microbes. So the calcium is really important for improving the roots and the fine root hairs. So if you're short on calcium, you don't have very good roots. If you have abundance of available calcium, you have all those fine little root hairs that are sloughing off on the sides. And what is that? That is the microbial feeding station of the plant. So its roots pick up nutrients, but they're also delivering to the microbes. And so what I find with soil and with growing and agriculture in general is that there is not a lack of resources. There's not a lack of energy. There is not a lack of inputs. There is a lack of stewardship. Okay? There's a lack of knowledge about what to do to create the best soil and to get the healthiest plants. Okay? And so by going through the garden program, I realized a few things. We need full spectrum nutrition. We need to address the majors. We need to address the secondary minerals. We need to address the trace minerals and the rare earth elements. So I always put the first base, second base, third base, fourth base. You want to hit a home run, address them all. Okay? And so that has been my approach, and so we started working out and testing food. So you can test food by taste, by Brix reading, or by analysis. And so taste is the easiest. You just go taste it. If it's got a good flavor and it's sweet, it's good. Brix reading puts a number to that. That's where you take the juice and you do that, where you put it on a refractometer and you measure the bend of light. Now you have an objective number. It's not a subjective taste. And so the third thing is you can actually quantify those minerals. So that Brix reading is total dissolved solids of minerals, carbohydrates, essential oils, all of those things. But when you analyze it, you can actually quantify in that. So that was my approach. And what we found is cannabis growers started coming and saying, well, we want to do the very best for this. And they started saying that connoisseurs would come and say that if you have hydroponic stuff, it doesn't taste as good. If you go organic, it tastes a little better. But if you go nutrient down, so the whole program for full spectrum nutrition, now that's the best stuff. Now I can't verify that because that's not what I do where I'm in Minnesota, but I am helping on the backside. So that's been my approach, and we're finding some very good results, and we think that nutrition is going to be one of the keys to really help achieve the genetic potential that's there in the plant already. The environment and nutrition is going to do that. So that's it, and I'll be happy to answer questions later.
Thank you very much. Well, actually, that's a really good segue for me to step in. To give an overview, I think most of us, depending on where you are, how many people have been in a grow room? Yeah, okay, and how many people are actual growers? Yeah, very good, very good. So you came from different places, some of them from basements, some when I call it bro, 1,000 square feet? Are you still bringing that same system in? So I think you have to go through, what is it that we want to do? And you have to treat the plant first. The plant has to be first, not the investor, not even the patient. The plant has to be first. And it's a sentient being. It's not a robot. It's a plant. It's a beautiful lady. So you have to treat it very well. And then how do you do it? And with us in our company as wellness, it's biomimicry in nature. How do you recreate that? And John said that very well. And then why do you want to do it? If you're trying to just get high THC, you can make a mutant plant. Because that's really what you're doing, right? In a sense, you can grow it with a flashlight. But when you want Panama Red, you want something that's been growing for a significant amount of years. Where do you get that? Where do you find that strain? It's not just the Marley brothers, right? There's other people that should have that because there's some healing qualities from all of that world. So that's the other thing. You have to make a decision. Patience, healing, medicine. Do I want to get into the blue-green business? What is it? What am I doing? And then how do you save and how do you scale it? And then how do you make money, right? Because you want to make money so you can do more. So you want to go seed to sell. So everybody talks about THC and CBD is so big these days. But how about the terpenes? How about the strain genetics? How about what's happening to that plant outdoors? Right now, 80% of the grow in California indoors. And yet, the outdoor guys up in Humboldt who grow probably the best stuff around don't get that money. Something is wrong. Because you're engineering it indoors. There's elevation, humidity, temperature, and then you have to put some stress on the plant. A little bit. A little bit of stress. And that's why you get healing plants from healthier products. So what we did at our company is we decided, how do we bring the one thing that's missing? All the shows you go to, I will guarantee you a significant amount of the vendors there are mitigating the fact that they don't have sunlight. If you only have 23% of the sun, you've got to give it something else to be able to grow a plant. So you go to chemicals. You go to NPK adding. You teach 17 different just to get that plant to even. But that's a problem, isn't it? Where does those chemicals go? Where do they go at the end? Anybody know? No, it goes inside your body. How much of it? You think there's an extraction process that takes out heavy metals and takes out any of the chemicals you're putting in it? No. It bioaccumulates. And then now you make hash. Oh my goodness. You've taken that and even... So you have to think about how to do it naturally. And so what I'm showing here is most of the solutions available to us. HPS was around, and there's a good reason. They had to hide. They had to be somewhere where they couldn't show they were lighting it up. So parking lot light. Yeah, let's grab one of those. And then LED comes along, and of course, there's a place for all of these lighting systems. LED was much more affordable, at least in the home sector, other than incandescent lighting. But it doesn't give you full spectrum. It gives you, and I think Kat said it earlier, my business partner who's sitting up here, it's like an orchestra where you can recognize the tune if the tuba section plays it. But you understand the whole symphony if every instrument's there. And with regards to LED, each frequency at a time. They don't mix. How are you going to mix those photons? And so all the quarter wave, eighth wave, the permutations that the plants are looking for never show up. But that plant is smart. It's smarter than the LEDs and smarter than us. It will make its way, and it will grow. It may not be full spectrum, may not be all its flourishing beauty, but people will play enough with it so you can get that OG Kush. And the OG Kush only came back because they wanted a shorter grow period, and they were trying to make money. That's how it started. So with our light, you can see the yellow line is the sunlight. The little line below on the bottom, you'll see it here as PAR. I'll move it here. This is where all the other light technologies are. And LED and HPAS is right in this range, a little bit over here and a little bit here, but a whole different, but not matching the sun spectrum. And we do it all the way. What does that do for you? Well, when you see a grow like this, 500 square feet, with 24,000 watts of lights, think about the air conditioning that you have, and you can see it on the ceiling. And then you get so hot, and you put cool air, and now you have condensation. Oh, let's get some humidity system. And by the way, I don't have UV, so let's add some salts. So what you're doing is resistive farming, not regenerative farming. It's all resistive. You are resisting that plant's nature by doing this. So what we do is 24,000 watts here, we replace it with one light. 1,000 watt light, okay? 24,000 watts, 1,000 same grow. In 20 minutes you can see what those plants look like. We recommend 5. So one of our lights is 100 square feet, 144 square feet, or if you're doing tomatoes, it's even larger. It's the sun. So it's the full sun. So what does that give you in land races? It gives you beautiful plants. It gives you the sugar that you're looking for. Even on the leaves, you can see it. So you can grow in living soil with 2 kinds of worms, just like John is dreaming about, indoors. You can do that indoors. And so you have a couple of choices. And this one I don't like to bring out all the time because it has to be the right crowd, but if you're doing everything on the left, that's poison. From the time you start, to the time you deliver it, to the time you extract it. But if you do it on nature's side, in sunlight, in living soil, completely organic, healthy, you get full genetic expression, you get entourage, ensemble effect. Not only are you actually helping the patient, but you're making a mark for yourself and some IP that sets you apart. So, I'm going to now send it over to Sarah. Savannah, rather. Sarah. Do you want to just do it from there? You want to come? Your choice.
Okay, yes, hello, I'm Savannah St. Clair. And one thing that I'd like to add about the interface between the tissue culture and the soil science side of things is that, especially during rooting, beneficial organisms can really encourage the process. So for us, we found that the ex vitro rooting has been the most effective. And at that time, we introduced beneficial organisms, and we're also going to be looking into doing that more to encourage rooting in vitro as well. So with the controlled environment, we're trying to emulate the optimal conditions in nature, and that would include life in the soil. The first part of the process is absolutely sterile because we want to kick out all of the bad guys, any of the pathogens, either on the surface or those that are systemic. And at the same time, because it's sterile, we're not going to have any of the beneficials, but we can introduce those later on. So.
There. So what I'd like to add to this is, with my background, I've been, I came from the farming industry, organic and conventional. I've been doing it for over 15 plus years. And coming into the cannabis world about 2.5, 3 years ago, one thing that's common and what I find with growers, when we get into a lot of facilities and we speak with growers and learn their processes and understand how they're doing business or how they're growing their crops. One of the aspects that I think that is always, they're always very inquisitive about, and that is plant health, managing fertility, managing the overall environment, and irrigation. Those are the variables, we want, as agronomists in the field, we want to maximize the genetic potentials of those plants, either in production or in quality, or well, not or, and quality. And so taking, with what Mike has done in his, tissue culturing and developing the genetics, the genetic potentials are built into these plants. And so our job as agronomists, or in-field agronomists, are to evaluate those different environments. So if that's indoor or out in the field and soil, there's a number of variables that impact the different operations. And so the approach that I like to take is that we look at the things that the crops are required, need or required, but where are we lacking in management or execution? Execution is so hard. Everybody's wearing 20 different hats trying to get a lot of these operations up and off the ground and in production. And so what we try to do is, one is apply and measure, or apply agronomy and measure. So we're dealing with a lot of monitoring in the sense of laboratory, if it's soil, if it's feed and grain, or if it's tissue analysis. So that we have some measuring stick to be able to make adjustments in our systems. And so I think with regards to, working in any environment that you might be in, those are the things that you should key in on, because those are things that we tend to see are not necessarily, it's just a slight lacking of either, it could be knowledge, it could be technology. So usually when you start to manage your fertility or your water more sophisticated, it takes a lot of labor, a lot of time. So starting to automate those processes, eliminating human error, that is, things that we look at as agronomists so that we can utilize all those tools to produce the highest quality crop and be able to do that time and time again. And sustainability. I work in organic systems, I work in conventional systems. Sustainability is a necessity in both systems, and there's ways to do it in both systems. But it's something that you have to consider as agronomists and as people that are, as myself, consulting with my clients, or I'm always trying to keep that in the back of their minds, that we can still produce high quality and we can still do it very effectively and efficiently, but we have to make sure that there's some sustainability built into that process. And if not, it can be a financial sustainability or even just an instance of quality. And so then you just don't produce as high a product or quality of a product. So it's just a little bit about, kind of my point of, or my perspective on what I see, what I do as an agronomist in field, in the greenhouses. And so ask away for any questions. So.
Thank you. Thank you very much. Well, I guess I'm going to ask the panel a question. When it comes to the overview that we wrote with regards to working within nature, and I think a word you brought up a little while ago, Aaron, and that's quality.
Yes.
Can you define for us what does it mean to have a quality cannabis? Most of the people here are doing cannabis. What is that within the purvey of your area of expertise? What is when you go to a client, what is that quality plant that you're talking about? How do you quantify it?
I think that quantifying quality is, there's two aspects of that. There's one in the sense of economical quality, so maintaining high productivity. The big aspect of that is quality in the sense of if it's terpenes or if it's CBD or if it's high pH loads. All that stuff can be extremely manipulated in the growing process, either for the benefit or even for the reduction of that quality. So there's a lot of things that play into that. But with regards to quality, it's having high productivity, having good, if you're looking, if your target is to have a high THC product or CBD product, just to maximize that genetic potential. Plants are a pretty resilient creature, and or plant, or organisms. So what happens is, we tend as people and as growers to retard a lot of that genetic potential and not be able to optimize that. And so, so there's a lot of perspective on what's good quality, but at the same time, it's producing a healthy crop. If you produce a healthy plant, it will produce high quality. Period.
Michael, your thoughts on that? You and I had and Kat, I think we were over by the railings there yesterday talking about this. Would you like to share with the audience with the area that you're working in? What are you thinking is a quality cannabis plant, and particularly for growers there? Because one of the things I just want to interject, high times to the study, and of course they're always doing studies, but the chart showed that overwhelmingly 44%, something like this, of those responding said quality was number one. And number two was the terpenes and flavonoids was number two. So if you just look at it, and then sustainability was done there, if you measure all those, it's more than half of what the respondents want. But then when you go out to a dispensary, are we finding quality cannabis or not? So with regards to what work you're doing, how do you think you can do where we get closer to Mother Nature, and what would your organization do?
Yeah, by observing how cannabis grows in vitro under very specific controlled conditions that we can manipulate, it allows us to pull data, and that data will guide our optimization process. Now, I think being focused on starter plant production, the finished quality of the plant is important to us, but what would define a quality starter plant for our group would be a healthy, stable plant that doesn't have any negatively impactful pathogens present, or bugs or pests on the plant itself or in the growing media. I think that's the most important thing from our perspective, and then also ensuring that the genetic stability of that plant, even though this is more of a breeder's issue, is passed on through all of our units at scale.
Okay, Savannah, what's your thoughts on that?
From my point of view, the quality for starter plants is going to also come from the consistency and the uniformity, both in terms of not having genetic variability and also having the same growth pattern and the same structure between all of the different plants in a lot or in a batch. And speaking to quality as it relates to sustainability, with plants that come without pathogens, that reduces or eliminates the need to spray pesticides by the grower. So the way that I would quantify it as well would be through customer satisfaction, because if there's a problem with the starter plants, absolutely the ministry is going to hear about it,
Okay.
or not, preferably, because you have quality plants.
John, what's your thoughts?
I think quality cannabis is going to have to be very effective for the consumer. So if the consumer can come back and say, that's really good, then everybody before that is going to win.
Okay, very good, yeah. The other thing is, we're just speaking about pathogens and the need to combat that, not only for a good strain and to get consistency. In the outdoor world, it's obvious that some of those plants get pathogens, but not as prevalent as indoors. Would you guys agree with that? Would you see it's more prevalent indoors, right?
obviously you've got naturally occurring pathogens that are going to impact anything outdoor. What happens with indoor cultivation is you tend to have an isolated pool.
Right.
And then within that isolated pool, things can develop and cultivate and be added. And over time, you can find yourself with a very dirty, pathogen-infested indoor environment, unfortunately.
Yeah, and I would say the reason for that is the fact that you don't have UV inside. You don't have the full spectrum of the sun. And typically, the growers we have experience with don't have those issues indoors if they have the full spectrum and all frequencies coming on, because it does control it. So that's another area. With regards to cannabis, good soil, I know, John, you talked about it here. What would be that mix that people should be looking for, you think? Because I would think terroir is very hard to replicate from somewhere else, right? But the soil, yes, but terroir with regards to minerals like wine production and such is unique to a very unique, if you start talking about Appalachian and you start talking about land races, you really, there's a taste, there's a flavonoid, there's all these things that come along, including all those compounds that you're trying to get full expression. What do you think it is with regards to the importance of what you do with regards to the quality of that soil to do that?
Well, I haven't looked at terroir and looked at it as I want to recreate this particular one. What I've looked at would be more what would be really high quality, what are the characteristics that they are, and then try to replicate that. So I would like to recreate more of a volcanic environment right in the growing mix by using various rock powders and various things that's going to add things. So I would use things like seaweed to give some iodine and silicon from the rock powders and different things like that to bring in the full potential for the biology and the roots. But I'm not thinking in terms of a particular region, but that would be my approach.
Okay, all right. So the whole panel, I wanted to ask a question. I'm going to open it up for questions. I really want to do that. Hopefully people have some. Why, there's a big push to take the cannabis into big ag, the way big ag is doing it. Vertical farming, all of that. But if you look at big ag, the only thing really they do indoors is leafy greens, of which there's nothing inside of them. Or if you get greenhouse, hot out tomatoes that like you want to, why would we want to go in that direction? And what are those things that we perhaps have learned from trying to grow food? And outside as well. You know, I'm not a big Monsanto fan. So how do we do something different with this beautiful healing plant that we have and not go in that way? Unless there's some really convincing reasons why big ag can come in and go, wow, this is phenomenal. Use my salt, use this, and you got great cannabis. I mean, why is Emerald Triangle still going? Anybody?
Yeah,
Please.
Sure.
Go ahead.
I'd like to take that on a little bit. So I think the biggest thing that this industry is going to have to pay attention to is going to be the commodity market. I think, and this is coming from, I come from a farming family. I've been in the business for a long time. And I've worked for some of the largest growers and some of the smallest growers. I think that industry overall, and how I have seen it evolved, we're lacking technology in conventional ag today in California. We're probably, if not the worst, we probably are second to the worst. Midwest has more technology than California does. And the reason that a lot of those drivers is because of commodity markets. And I have a lot of contacts that we deal with on a daily basis that you talk to these growers and you talk to them, they understand that if we have a more biologically enriched soil, it's more productive. We understand it's healthy, it's more sustainable. But the problem is that their margins are so dwindled down because of the commodity market that they can't afford it to stay in business. And so we've implemented this market in ag over the last 50, 100 years that the growers can't invest into their business. They can't invest in technology. They can't invest. Now you have the Winsets or the Howlings of the world, but they're very minimal on that market. And I think on the cannabis side, And right now we have a lot of, it's a very lucrative business. And we're able to invest in those technologies, which is good, because one is we have better control, two is we have a lower cost per unit, so there's more profit per unit. But at the same time that's a lot of that drivers. I think, if this market can not go down the road of conventional ag in California or anywhere around the world, you will see that we will be able to sustain the industry better. We'll be able to sustain the technologies and the high level of growing. And that's where it should be. That's where it should have started for ag 50 or 100 years ago. They should have pushed it as progressively as possible, but they didn't. And a lot of that is because of the market, the dollar behind it. There wasn't enough. So you and I, when we go to the grocery store, we don't have, we're looking for, you're starting to get more organic products and stuff in the store and pay more for them, but overall, the general population wants that cheap product. And you're right. Tomatoes, 20, 30 years ago, tomatoes, they were wonderful. Now you get a tomato and it's water. And the reason is because that grower is not investing in the nutrition to develop the sugars to have that flavor, because he can't afford it. And so he's working off of a very tight budget. And you'll see that across, and that's what hopefully does not ever happen to the hemp and cannabis world, because we have an opportunity as an industry to really do it right this time, right? So that's kind of my take on that.
Okay, thank you very much. I want to open it up for questions. I don't know if people have any. Otherwise, I have a bunch. Go for it.
So my background is similar to Aaron's. PCA also for conventional and organic and and one of our challenges is low profit margins. It's not an option for cannabis. So with some of those challenges, we've got labor. What's your guys' perception on AI and moving us in that direction and helping us with some of those challenges?
I can speak a little bit to this. I see a major influx of investment by all the major tech companies currently on the digitization of horticulture. Now, whether that's just strictly data collection in the field, which is a fundamental part of any AI system. You've got to have data to feed AI to get quality results. The development of these types of tools are kind of in their infancy now. We're just seeing them in Silicon Valley. I do expect that over the next 10 to 15 years that you will have the opportunity to leverage an AI system to help you to optimize your internal cultivation. A lot of that could be genotype specific, perhaps with the cannabis space, if we have the opportunity to collect that level of data.
I think that ultimately we're going to have the commoditization is such a big issue that always happens with various industries. And I think the way to compete against that is to really compete against mediocrity, and it's usually that section in the middle. So you got growers and you got consumers, but in between you have a system that wants to reduce the cost completely, as much as they possibly can, I should say, and so they want to pay the farmer less, and they want to do everything less. And so I think to overcome that, we have to think about ways that we should be paying the farmer more, and we need to create that middle system that pays the farmer more for more. And so the worst thing of all is to pay more for organics and get a low quality, right? Then you feel really bad. Okay, so we need to have the standards that say, well, this is the best we can produce, and we want to pay the farmer more to get that.
Any more questions? Yeah? Nobody? Wow, interesting. Well, we have a few more minutes and then we'll close down, but I guess the question left is, at the end of the day, which is what I started out, is what is it that you're left with as a plant? Whoops, sorry about that. I started clicking. It doesn't matter. Let me just unplug. Oh, sure, go for it.
Generally, how much is lost to mold deterioration in a grow room?
That, I would say, I would go to John, but that depends on the growing method and and the region and the way people put together their grow, I would think, but
I don't have the answer. I don't grow. I'm sorry.
yeah,
In
that's,
Minnesota, and it's not.
I mean, if you're not going to be,
Places for the answer to that question.
well, okay, look, it's like in a greenhouse. A greenhouse is a petri dish. Don't forget that. I mean, you know, when people think greenhouse is the way to go, you're really creating a great home for all those things to, along with your cannabis.
The reason I asked that question
Uh-huh.
is I produce a product that eliminates the airborne pathogen
Mhm.
in the grow room.
Okay.
I want to know whether I'm in business or not.
Ah, there's a lot of people.
I could come out a little bit. I think when it comes to losses related to mold, you actually have to look at the organisms specifically. I think a great example is the difference between powdery mildew and botrytis. Botrytis, you will get mold, bud rot, but it's somewhat isolated. Now with powdery mildew infestation, it's usually going to be systemic throughout the entire room. So again, I think you would have to really focus on the specific organism to really define its impact on your average cannabis crop.
Okay, we've done some studies about that in a couple of college and university studies. And we find that no matter what it is, if it's smaller than about 10 microns, it goes airborne. Smaller than about 20 microns goes airborne. When these pathogens, particularly mold, when they sporulate, I mean, they're like dandelions. The air carries the seeds elsewhere, and they reestablish themselves. We found that it didn't matter what kind of particle it was. We were removing it from the atmosphere, and we're saving those crops. And we do this in potato storage, okay? Potato storage, they don't have potato diseases if they vacuum those pathogens out of the storage area. We can do the same thing with cannabis in the grow shed. And that is a big benefit. We see no disease and no chemical.
Okay,
Let's say something.
sure.
So I'm involved in quite a few different build-outs of greenhouses, and when you're talking to a grower, you know, he's taking into consideration all those factors, and he's going to invest in sanitation practices. He's going to invest in you know, ways to reduce that exposure. I think that you're always going to have some aspect of pathogens moving through a system at some point, but the thing is putting those tools in place that can mitigate the impact on the production. And so, and if that's scouting, you know, making sure you have a scout, somebody walking that grow, that greenhouse on a, you know, every other day, and making sure. So it's a very dynamic process, but I think, like you say, you have a product that, you know, you're dealing with air and movement of air and movement of spores. All of that is under consideration when a PCA or an agronomist is walking through those facilities. The other thing too is people. People are one of the biggest transmission of diseases. I mean, in any system, no matter if you're outdoor or indoor. So sanitation is really big. And so, you know, not getting into the application side of, you know, pesticides or anything like that, you have to have a program put in place in order to mitigate that. The other aspect of that is growing that plant, because plants have a pretty good resilience against disease, matter of fact. But you have to have a very healthy, well taken care of plant. And when I say healthy, good soil environment, good fertility environment, good irrigation practices, good environmental, so lighting, temperature. Temperature could play a huge effect. We minimize the lengths of our grows because if they get beyond 150 feet on some of the tunnels, we can't have it because we'll have botrytis outbreaks because the wind is, we don't have, it's a very stagnant, very high humidity temperatures. And so when you create the environment for botrytis or mildew to thrive, it will try